Hello, everyone. I hope you had some good food. Yeah? Hamburgers and stuff? Yeah? Cool. What are we going to be doing? We are going to be looking at Xamarin Android. And I'm going to, in the next 60 minutes or so, explain you how you can build, well, a small working application using Xamarin Android. So let me first introduce myself very briefly. My name is Gilles Kleren, coming from Belgium, here for the third time at NDC. Working as a mobile architect at a company called Ordina, where I focus basically on the Xamarin projects for quite some time already. If you have any questions on Xamarin development, please feel free to contact me via Twitter or via email. And I'm proud to say that I'm a Pluralsight author. I have been so for 3.5 years, I think. This session is a 1-hour session, of course, but I'm creating a 4-hour Pluralsight course on building a fully working, a more extensive application in Xamarin Android as well. The one on Xamarin iOS is online. It's basically also a copy of the Xamarin Android application, so it's the same application which gets built. I have one on WPF, and I have a couple of on HTML5, so if you have any interest, pick up a free card for one free month at the booth of Pluralsight, and you can take a look at this course in some more detail. All right? So what are we going to be doing? Very briefly, I'm going to show you the Xamarin story. What is Xamarin? What is Xamarin Android exactly? How does Xamarin Android fit in Xamarin, and how do they relate? And then we're going to dive into building that application. So the first thing that we're going to be looking at, because I'm going to explain the Android concepts, because you have to know the Android fundamentals to actually know about Xamarin Android. So I'm going to explain those, and while we're doing that, we're going to build a detail screen. A detail screen that has a couple of views on there, and we're going to see how that relates to the activities and the fundamental things that we have to learn in Xamarin Android. Once we've done that, we're going to take a look at how we can create lists and how we can actually create a list screen, and from there navigate to the detail screen that we have already created in the first part. If possible, but I don't think we can do that in an hour. That's normally a 75-minute session. We can also look at fragments, but let's not go too deep in that. We're going to take a look at how we can optimize the application, how can we do translations in the app, how can we add the correct icons and stuff like that, and then we're basically ready to prepare the application and to publish it in the store. So that's what we have for the next 60 minutes. So by the time you walk out of this room, you will have understanding of the basics, the fundamentals of Android development, and therefore also Xamarin Android, because it's basically wrapping around it. And you will see how a fully working application can be built using my favorite tool at this point, Xamarin Android. Now, before we take a look at how we can build things and how Xamarin actually works, let me show you what we will be creating. So the scenario for this particular talk is called the Android Coffee Store Manager. It's a basic master detail application with on the first screen a list, and then when we click on an item, we will see the details of the coffee that we have selected in the first one. So let me quickly jump to my demo environment, and let's make this a little bit bigger. For some reason it's kind of small now. So this is the overview screen, so the list screen. And when I click on one of the items here, I will be navigating to the detail screen, on which we have a text edit text control here. And we can scroll up and down, so there's some scrolling in there. There's a toggle button in there, there's an ability to add a date, and so on and so forth. And when we click on the Save button, we're navigating back to that first screen. So that's the scenario that we'll be looking at. So it's a very simple master detail screen, but if you think of it, many applications don't really need that much more than what this application will be adding. So let's take a look at how we can actually get this to work. All right. So most of the time when I do Xamarin talks and Xamarin Android talks, many people have heard of Xamarin. So let me briefly give you an overview of what Xamarin is, what Xamarin Android is, how the two relate, and then we can look at the code to build this application. So Xamarin in itself is enabling us to build cross-platform applications. Now, the cross-platform paradigm is nothing new. It has been around for quite a few years already, and other technologies have emerged to do cross-platform. Mostly are actually focusing on the web stack, that you build your application in JavaScript, HTML, CSS, you put that in a web view, you wrap it as an application, and boom, you put it in the store. That is not what Xamarin will actually build for us. Xamarin will actually compile into native applications. It is not a cross-compile. And I'll show you in a couple of slides how actually Xamarin is compiling your application. But what Xamarin will output, is both Xamarin Android and Xamarin iOS, is a fully native application. That has a couple of consequences. The first one is we have the ability to use the native user interface elements. When we're building an app, and we put a button on the screen, we're actually putting a UI button in iOS, an Android button in Android on that screen. It's not an emulated button, it's not a fake web button, it's a real button. We also get native performance. We're building a native app. It's as performant as an iOS Objective-C or a Java Android application. Independent tests, many bloggers have done some tests on the performance, and sometimes it's even faster than the native compiling. So it's actually really performant, these Xamarin applications that we're getting. Now, just saying that we're going to write our applications in a cross-platform way would not be a selling point. For us, of course, as .NET developers, we actually extend the reach of our knowledge. We can actually write everything from top to bottom in C#. And one of the main benefits is the fact that we can share code across platforms. Normally, when you build a native application for iOS, you build it from top to bottom in Objective-C. In Java, when you build the Android application, and in C# when you build the Windows Phone application. Now, by using Xamarin, we can actually reuse a lot of that code. Because if you think of it, accessing a service in Android and accessing a service in iOS is basically the same thing, but you have to write it twice if you want to target the two platforms. And the same goes for the data layer and so on and so forth. So many times sharing code between the different platforms will save you a lot of time. And I'm coming back to that, and our application as well will be built with that in mind. Now, when you download Xamarin, it's actually, when you have Visual Studio on your PC, it's actually just a tool set on top of Visual Studio. It installs itself in Visual Studio. If you don't have Visual Studio or you're using a Mac, it will actually come with its own IDE, and that's called Xamarin Studio. I'll be using Xamarin Studio, but what I'm doing here in Xamarin Studio, you can do it in the exact same way in Visual Studio. It's a commercial product. There's a license involved. A license of, if you use the full edition, is about 2,000 euros per year. So that's, I think, around £1,500 per year. But there is also a free edition. If you install the trial, let it expire, it will keep on working in the so-called starter edition. And you can actually publish apps in the store with that free starter edition. There's a couple of limitations, but I'm not going to go there. You can find it on the website. So basically what we are doing with Xamarin is we are extending the reach of our C# and .NET knowledge. We are no longer limited to just using or building apps for Windows. We can also build now apps for Android, for an iPhone, an iPad, iOS in general, even, of course, Windows Phone and Windows Desktop as well. That remains the same. Xamarin is not really covering that. And even Xamarin on the Macs, you can also target that platform. Basically meaning that using Xamarin, you can target billions and billions of devices using your C# knowledge. Now, Xamarin itself comes basically with three major platforms, three major frameworks, let's say. Xamarin Android, that's the goal of this talk. Xamarin iOS is the second one, and Xamarin Forms, that's the other talk. Xamarin Forms is a completely different thing, allowing you to build even the UI also cross-platform. I'm not going to go there. We're going to focus on the real Xamarin, so the traditional, the classic Xamarin, and that's Xamarin Android that we are going to be looking at. Now, where can we run those Xamarin applications, or Xamarin Android applications? Everywhere. Everywhere where Android is running, you can also target that with Xamarin Android. So that means that if you have a watch, a Samsung Gear, a Motorola 360, whatever device that comes out with Android or whatever watch that comes out, you can target, you can build apps with that using Xamarin. If you have a Google Glass lying around somewhere, no one is using them still, so you can actually write Xamarin Android applications for that. A Kindle Fire, a Kindle phone, it's running Android, so you can actually build or you can target it with Xamarin Android. So basically everything that Android, where Android is running, you can actually build Xamarin Android applications for it. Now, what are we going to be doing? We're going to be writing C# top to bottom. We're going to be using .NET. So basically that means that the system namespaces, system XML, system IO, system link, all the system namespaces that we know from .NET are going to be included in the Xamarin Framework. So we don't have to learn a completely new framework, or we don't have to learn Objective-C or Java to write Android applications. No, just continue using C#. But if you think of it, well, just using .NET and just using C#, we probably are not going to be able to all of a sudden target an Android platform. And that's exactly where Xamarin is actually coming in. Xamarin will basically fill that gap, and that's this part here. You can think of Xamarin as being like a wrapper, a wrapping layer around all the Android APIs, the native Android APIs. And that's how we can target them using C#. We don't have to write anything else. We can talk with sensors. We can write code that works with an action bar. And the action bar is the tabs that you have, for example, in the Google Play Store. We can use the NFC sensors, the text-to-speech APIs, all APIs that are natively accessible or available, let's say, in Android, are available from Xamarin Android as well. So there's no compromise. It's not going to happen that the designer or the architect has created the application layout for an Android application, and you're going to say, well, we're going to build it with Xamarin Android, and you look at it and you say, that's not going to work, and that design is not going to be one-on-one the same. No, not going to happen, because we are actually still using the native SDKs, the native APIs, but from a C# perspective. We're actually talking with them using C#. Now, Xamarin itself, how does it work? Because it may be a bit of a head explosion that all of a sudden you can now target Xamarin, Android with C#. Why have we not been doing that for so many years then? Well, actually, it works because of a couple of things. I just said that in the previous slide here, we are actually going to work with system namespaces. And we are actually working with the .NET framework, but we're working not with the real .NET framework, we're working with the Mono framework, the open source version of .NET, which has been around for so many years already. It has been around almost as long as plain .NET. So the Mono framework is an implementation that was actually written by the same people behind Xamarin. So it's not something new. It was already written in 2001 and has been maintained all that time. So basically what happens is your application that we're going to be building in Xamarin Android is communicating with the full version or the part of that version of the Mono framework. And that Mono framework as source will be compiled into that application, giving you the ability to talk with system namespaces and so on and so forth. It's going to be packaged inside of your APK, because the Xamarin Android application is also going to become an APK, an Android application package. And that Android application package is installed on the device here, and it actually, like your .NET application on your Windows PC, installs like a runtime. It's called the Mono Virtual Machine. It's like a runtime. And it will do just-in-time compilation of your code towards bytecode. It's basically IL that is compiled. It will compile itself into bytecode when the application is running. That's it. That's basically how it works. Why did no one think of it so many years ago? And so, of course, your Mono Virtual Machine, so your runtime, your Android runtime, your Xamarin Android runtime, will communicate with the virtual machines that come by default with Android. And this gives us the ability to do basically everything that we want or that we can do on an Android device. Now, like I said, one of the other benefits, apart from the fact that we're writing native applications, is the fact that we can share code between different platforms. And that's also a big plus. Because when you as a company start building a mobile application, you build the iOS application. And then you say, well, now we have to bring in an iOS team, so they will build that application end-to-end. Boom, it's done. Now it goes in maintenance. And then they say, well, let's now build the Android application. Let's bring in a Java team, they will build it. And those teams, they cannot communicate. The developers, they cannot communicate, but anyway. So they cannot exchange any code. Now with Xamarin, we're basically not having that problem, because you can now write once all the code that is basically not the UI code. So the data access, the surface access, the model classes, all the things that are somehow shareable, write them once and give them to the different product teams, or the different project teams, let's say, and they can actually write their applications on top of it. All that code is C#. All that code can be written once and shared across projects. In general, we see for the projects that we've been doing, depending on the project, an average code reuse of around 50 to 60%. Xamarin themselves say quite high. They sometimes say even 80%. That's marketing talk, in my opinion. Normally, we end up around 50 to 60%, depending on how much business code there is. But in general, that's, of course, still a big plus, a big advantage if you can reuse that much code instead of having to write everything 2 or 3 times. Now, how can we do that? Well, you can do that using something called a shared project. If you've ever done any Windows 8 development, well, this is the Windows 8 Universal application talk. That's not something that I recommend using because it gives quite a lot of clutter in your code. The recommended way of writing shared code is, in my opinion, the so-called PCLs, or portable class libraries. Basically, a portable class library is just a class library which can be referenced from different project types. And I'll be using that in the application as well. So the architecture that you end up with is something like this. You will have a lot of shared code. Like I said, this is that 50% or so of your code base. In there, you will have your data layer, for example, a SQLite, maybe file access, those kind of things. You can write that once. It's all the same. Data access layer, communicating with that data layer. Service access layer, communicating with a REST service in .NET. There's a couple of options to do that. Well, do it once and then plug your mobile apps on top of that. The business layer, the model objects, so your model classes, write them once, put them in that shared block here, and then on top of that, you will have your different mobile applications. The iOS app, the Android app, and the Windows Phone app. We are, of course, going to focus on this thing here. So what we'll be writing here is the actual way of writing a UI in Android, XML. We'll show that in just a second. And we'll have some code here. Normally, that would have been Java code, but in Xamarin Android, that is C# code as well. Okay? So what do you need? And then we'll really start building that application. I'll quickly show you what you actually need to get started with Xamarin Android. Now, getting started with Xamarin Android, you can just take out your PC, install it, and you're good to go. You really don't need a lot to get started. Like I said, it's a commercial product, Xamarin, so you will need a license, but you can install the trial and actually go from there. You can use a PC. You can do everything that I'm doing here on the Mac. You can do everything on the PC as well. Install Visual Studio and install Xamarin. Xamarin will plug itself into Visual Studio, or you can also use Xamarin Studio, the IDE that comes with Xamarin. It will also take care of everything that you need in terms of Android SDKs, because there's quite a lot of things that you have to install on your PC, including Java. Your PC is basically now open for the rest of the world, but anyway. You will have to install it will install, let's say, the Android SDK. It will install emulators. They're not so good. It says here emulators twice. There's a reason for that. In just a second, I'm going to explain you why. And I also, of course, for all mobile development, do get a cheap device. A €100 device is actually the best thing to test an Android application on, because they're slow. And if the application runs on a slow device, it will also run on a good device, on a high-end device. So install it. Next, finish. It will do everything for you. Like I said, it will also install the Google SDK, and it will or the Android SDK, and it will also install emulators. Now, those emulators are good for one thing, in my opinion, that's drinking coffee. Because you click on something, you can go get a cup of coffee, and by the time you're back, it will actually have reacted to your click. They're so slow. Don't use them. So they're installed. Let them do what they want. Instead, use another emulator. My personal favorite on the Mac platform is Genymotion. There's a free version of Genymotion that you can use. If you're on a Windows PC, and when I work on my Windows machine, I use the Android emulator from Microsoft, which is a Hyper-V image, very good, very fast also from Visual Studio. You can download it separately, so you can actually use it from Visual Studio 2013 or 2015. There is an Android player from Xamarin as well. that as well as Genymotion use VirtualBox under the covers. So if you're on Windows, Hyper-V that's why I like Hyper-V on Windows. So on the Mac, I recommend Genymotion. There is going to be an Android player for Xamarin, from Xamarin for the Mac as well, but that's not released yet. All right, so that should give you an overview of what you need, what it is basically. Let's now get started by building this thing. So we're going to start building that detail screen. Now that detail screen, before we get there, I have to explain you a couple of fundamentals because I don't think anyone here in the room is really an Android developer. And developing in Android is, well, kind of a bit of different. Some concepts are completely different from what we know in Windows. So that's why I have divided the talk in a couple of fundamental aspects that you need, and then we're going to apply them in the demo. So we start from File New Project, and a couple of years back, when I would have seen this screenshot, I would have thought hell has frozen over because there's Android in Visual Studio and there's iOS in Visual Studio. But no, that's because of the fact that I've installed Xamarin. So there we have iOS, and somewhere over there, here, we have Android. And when you click on Android, a couple of project templates will appear. The first one is the one that you should be taking, the blank app. Now, why am I emphasizing that? Well, when you use this template, Visual Studio, or Xamarin in general, will take a look at the highest installed version of the Android SDK. So whenever a new version of Android is released, Android 5, Android 6, there's a new version of the API released, and intermediate releases are quite common as well. For example, when you click on that blank app, it will look at the highest version of the SDK that is installed on your machine, and in Android terms this is called API levels. So we're currently at API level 24, that's Android 6. It will automatically reference basically, or will register your application so it can run on Android 6. Click on that File New Project, and you will get something like this. Now, if you look at this, well, this is the Solution Explorer with some files in there automatically created for us. And we're going to have to take a look at some of these files because there's quite a few things that are a bit different than in the Windows world. Do keep in mind a couple of things. There's a folder called Resources. There's a folder called Drawable. There's a very important folder here called Layout, inside of Resources, by the way, with a file in there called main.axml. There's a folder Values with a file strings.xml. That's an about file. This file is going to be a very important file, resource.designer.cs, and then we have a file here called main activity. Keep those things in mind. I'm going to explain how the different pieces of the puzzle fit together. And let's start with the one at the bottom, that main activity. Now, activities in Android are probably the most basic building block that you have. An activity is more or less a screen, the functionality of a screen. And while I say that it's not 100% true, but in general, for now, you can understand it that way. Let's say it's the code behind. I shouldn't be saying that, but it's the code behind for a screen, let's say. Yeah? When you look at the Android documentation, you will see that an activity is described as being all the code to have I think it's all the functionality for a specific task. Now, most of the time, a task is probably one screen, and so an activity, let's say, is the functionality for one screen. Now, how should you imagine Android? It is not, and this is completely different from Windows world, it is not like a bunch of or one application which is starting up. An Android application is really a collection of activities. You can imagine Android as being a sea with all kinds of islands in there and disconnected islands. And they don't have bridges between them. And those little islands are activities. Each of those islands have a particular task. And I'll come back to that analogy later on. So the activities are basically the building blocks. And that's also a very important one. Because the second line here says apps don't have an entry point. The activities are the building blocks, but apps don't have an entry point. How do you normally start an application? Main. Well, go and look in an Android application. There's not going to be a main in there. There's one activity that you will mark as being the startup activity. And if you change it to another activity, well, that screen will then start. You can actually mark more than one activity to start, and it will actually launch them on top of each other. Kind of weird, but it's possible. So basically, whenever the code for one activity is executed, then the entire application is loaded into memory, and that application becomes then the running application. I think I've said most of the things that are on this slide already. All right. So activities, classes, are your most important building block. Now, an activity in code is basically just a class that inherits from the base activity, a class that comes from Android, has been wrapped by Xamarin Android, and that's why we can here reference the C# activity. Now, just by making it a class that inherits from activity doesn't really make it an activity yet, for Android, that is. We have to add this attribute here, activity. Because of the fact that that attribute is there, at compile time, Xamarin will take a look at all the classes with this attribute and take them and put them in the manifest file. Android, when the application is running on a device, will look at all the activities in your application. There's a couple of parameters on here. The label is this thing here. The main launcher parameter, equal to true, is an indicator to saying to Android, when the application is running, when the user taps the icon, this is the activity that should be launched. Main launcher is true. So by default, you will have only one of those in your application. And then we have the icon, that is this thing here, and well, that has kind of a weird syntax, doesn't it? Add drawable/icon. We'll come to that syntax in just a second. Bear with me for a second. So that's the activity. Now, an activity is, like I said, the building block of Android. Android applications are built up out of a number of activities. And they are very important to Android. Now, that's also why the life cycle of an activity is of an application is basically is directly related, let's say, to the activity life cycle as well. Now, if you look at the activity life cycle, I couldn't fit it on one slide to make it readable. This is the activity life cycle. An activity itself can be in a number of states. If it's viewable, then it's probably the running activity. But before it's actually running, a number of events will be fired, and when another activity comes in front of it, another screen comes in front of it, that activity will basically be put to sleep, and it can be in the paused state, it can be in the stopped state, it can be destroyed, and so on and so forth. Now, I'm not going to go too much in this life cycle, because there's quite a few things that you have to learn to get that life cycle to work. In most cases, most of your code will go in the so-called onCreate method. Do keep in mind that when the activity changes state, when it's visible, when it's not visible anymore, events will fire in your code that will actually say, well, oh, we're visible, oh, we're not visible anymore, we have to do stuff. Well, one of the most important ones that will always fire is the onCreate. The onCreate is running, is firing when your activity is going to be created. Let's skip the other ones for now. We are going to write our code in that thing here, onCreate. So we have the activity, and we have an override of the onCreate. Now let's focus our attention on the next line here, setContentView. setContentView. So basically, the activity is just a functionality for a screen. We don't have any UI code yet. Well, that UI code is going to be linked, let's say, with this activity using this line. setContentView, which is going to be the view for this activity. And then I'm passing it something, resource.layout.main. If you think back of this folder structure that was created in my application, in my Solution Explorer, I had a resources folder, a layout folder, and a file called main.axml. That's probably something to do with this. Well, I'm going to show you the glue between the two. Before I'm doing that, let's quickly take a look at the views thing here. The views indeed are files, the physical files, which are located in a folder resources layout, and they have an extension AXML. In Android, native Android, they're XML files. Here they're called AXML, Android XML. They're one-on-one the same with native Android. If you have an existing Android application, take those XML files and you can actually drop them in a Xamarin Android application. They're one-on-one the same. There's nothing different. That is why I said in the beginning we're using native user interface elements. So this is what you get in Visual Studio or in Xamarin Studio when you open one of those XML files, and when you click on source down here, it will actually show you this. And let's zoom in on that a bit. XML code, plain XML code. It's very readable. If you've ever used XAML, well, this is pretty easy to understand. It's a declarative way, or HTML, it's a declarative way of building up your UI. At the very top, we have a linear layout. Android, the applications run on all kinds of devices. So laying out everything correctly on all these devices is sometimes quite a bit of a difficult job to get right. And that's why Android comes with layout managers that manage how its children will be laid out on the screen. And one of the simplest ones is the linear layout. And like the name gives away, it will lay out its children in a linear way. In this case, vertically, so it will actually position all its children below each other. What are a couple of these very simple controls in the view? Well, we have the text view, that's your label. We have the edit text, that's your text box basically. And we have a button, and that's the one that you have here. Nothing very difficult. Now, when you look at the code, it's still quite readable. There's one thing that should get your attention. The ID. The ID has been specified here, add plus ID / text view 1, add plus ID, edit text 1, and so on and so on. There's quite a weird syntax, quite a weird way of writing those IDs. Now, how is actually, what's this all about? And that actually brings us also back to that resource.layout.main that we had in just a second. Now, like I said, so my views live in this XML file here. I'm setting my view, I'm linking my view with my activity by setting or calling set content view resource layout main. So basically what happens, or what seems to be happening, is that Android is looking at this directory, that is resources directory, and everything that is in there is going to be, let's say, typed or so. That's what it actually looks like. Well, that's more or less the same. Now, Android internally works with something called resource IDs. Everything, and I really mean everything within that resources directory, gets an ID. A file, like a view file, gets an ID. Even a control inside of that view, like we had here, also gets an ID. And that ID is of type integer. So basically, what happens is that when you compile your application, there's a file generated for you. And that file is a reflection of all the resources in the resources folder that you can access from code, basically. So this ID class is generated for you. And like I said, Android works with IDs for all your resources. It will actually generate those IDs. But when I talk to you and I say, well, we need control 210535570, you're going to say, excuse me, which one was that again? We don't want to work with that. So we actually need some way to link those resource IDs with values that we understand, with strings. And that is what Xamarin is doing for us in a class per resource that is going to be generated inside of your resources folder. I'm going to show you that in just a second from code. And once you have that, you can actually link the view and the code, and you can actually the view and the activity, and you can actually access your controls from code. By now saying resource.id.myButton, calling the so-called findViewById method, it's a generic method, so you have to pass the type, you can actually, in your activity, access the views from your view file. Quite a different way of working than what we have in Windows, where we simply access those things automatically. Now, one slide before we go to the demo. Like I said, activities have that activity attribute on top of it. Now, all these attributes, everything that is inside of your application is going to be described in one file, and that is the manifest file. So everything that your application contains, views, resources, activities, are all wrapped or all described, let's say, in one file, and that is the application manifest file. All right, let's take a look at how we can actually now see that running inside of Xamarin Studio. So let's go to the first version of this demo. There we go. So, if we run this now, and I am going to clean it because the applications all have the same name, and sometimes it doesn't really clean and uninstall it correctly when I just compile. So I am cleaning application between runs. and if we run this, we should now actually see appear in just a second the detail screen of the application already, and then we're going to see how things fit together to get to that detail screen. Sometimes takes a couple of seconds to get there. There we go. So there we have the detail screen. How did we get that screen, and how did I get my data in there? And I think there's also an event here that pops up a little message box here that says, okay, you saved this coffee. So how did we get to this particular place in our code? So this is the solution. First, I have created my application with the fact that I'm going to probably build an iOS application in mind as well. So I took out all the code that I could share between platforms, and I've placed that in this Android Coffee Store core project. So what do you typically put in there? And I know this is demo, so it's very simple, but model classes are going to be typically in there. There's going to be a repository in there, which in this case just returns a hard-coded coffee, but could perhaps go to a service, could go to a database, and so on. And then you have your service layer that works with the repository that typically goes in there as well. All that code is in just an external project. It's of type portable class library. So all that code goes in there, and that is, of course, just now referenced with a simple reference from my Xamarin Android application. Now, like I said, the Android application that we have here is starting with an activity. Main activity, you can name it whatever you want. It's not required. It's not a convention even. So let's take a look at that main activity. It's a class which inherits from the base activity coming from Xamarin Android. When we do a go to definition, we can see the class activity. And as you can see here in the Explorer here, there's quite a few things on that activity. I don't think we have time to look at all of these, so let's not do that. So activity comes with quite a few things, and to make it an activity, add the activity attribute at the top. The label is the name. The main launcher says, this is the one that I want to start when I launch my application. And the icon, well, that's that weird syntax again as well. We'll come back to that in just a second. I call the set content view, passing in resource layout main. That is actually an integer, like you can see here. Now, resource layout main is that file here. Let's open it. So it will open the designer interface with a toolbox that will allow me to drop something in there in just a second. So for example, if I want to add a button here, the green lines indicate where I can drop that button. Not going to do that because then I will mess up my interface. Take a look at the source here. So I can scroll in my application. So I've put at the very root a scroll view. In there, I have placed a linear layout, which allows me to place all my controls below each other. And then we have an image view. That was the image at the top. Text view is that label, and edit text is that editable text. Do keep in mind that we have those special IDs here. I'm going to come back to those in just a second. Now, in my activity, over here, we had called set content view, resource layout main. When I do a go to definition, I will not go to that AXML file, no. I will actually go to a class layout in which there is a constant int main. And that's that resource ID that Android has generated for me. This is the file that we now have open is this file here, resource.designer.cs. That file is every time that Android is recompiling, or that my Xamarin Android application is recompiling, is being regenerated. So don't change it yourself, of course. The layout becomes a partial class. Of the main, so the surrounding class, the base class is not the base class, the external class is actually class resource layout main. And there's also a class ID being generated here. ID is actually mapping to all those IDs here that we have created for us in the view file. So we have a coffee ID label, coffee ID text, and so on and so on. Once we have those generated for us in the activity, I'm calling my shared code here, get me a coffee on the data service, and then I'm passing that to this method bind data. And in the bind data, for example, let's take a look at this edit text here. I'm going to call find view by ID, passing in the type I want to get, and then I say resource ID coffee name text, and that gives me access to my edit text finally. And then I can actually put some data on there. That's what I'm doing here. Coffee name text is coffee.coffeename. And that's how we have actually linked up everything together. Is that clear for everyone? All right. So let's go back to the slides and let's continue. When we looked at the application in the beginning, we actually also wanted to have navigation from a list view. Now let's first add that list view and then we'll add navigation. Now list views are the way of adding a list in Android. Pretty simple. Mobile applications need lists all the time. Settings are lists. Music in Spotify is a list. All those things are actually, most of those are actually list views. Now, it would be pretty simple, but again, it's a bit different than what we're used to in a Windows world. What do we do in Windows? We say list view or whatever dot item source is this observable collection and do stuff with it. Display my data. Well, in Android, that's not the case. In Android, and by the way, it's more or less the same in iOS, there's an intermediate class that sits between. And in Android, this thing is called the adapter. The adapter is basically your thing that you are going to push your data to. Your list view is actually connected with the adapter and asks the adapter for the correct data. If you've ever done ASP.NET and you've done the object data source when we were all small kids, that is basically an adapter. That's the same paradigm that is being used here. So the list view is the visual part. The adapter is the thing that loads in the data that we push the data towards. So this is what the list view looks like, a very basic list view. You can add this thing here, which is called the thumbnail, or sorry, the thumb, not the thumbnail. And when you actually have a lot of data, it's recommended that you section your data. I'm not going to show you that, but it's pretty simple. You section your data, and you can have a little overlay that shows what section that you're currently on while you're scrolling. So which are the important classes here? The list view, the list activity I'm going to show you in just a second, and then that adapter. There's a built-in adapter, array adapter. I don't think you'll often use that. Most of the time you'll create your own adapter, and that's what we are going to be doing here as well. So let's take a look at how we can actually display some data. So this is probably the simplest way of displaying a list in your application. As you can see, my activity is not inheriting from activity. It's now inheriting from list activity, a different type of activity that comes with the Xamarin Android SDK. There are quite a few built-in activities. And this list activity, well, I think by the name you can think what it's doing is displaying a list. It has a list view built in. And that list view is already linked with an adapter property. So the only thing that I need to do to display data here in my own create is say, well, dear adapter, the built-in list adapter of this list activity, I want you to display some data. So I instantiate you as being a new array adapter of strings. It's just going to display strings. So this is going to look very plain and simple. And I'm passing in some data, and I'm also passing in how each individual row should be displayed. And notice here something different. Normally we had resource layout, simple list item 1 or what have you. Now we have Android. This is a baked-in resource, a built-in resource that comes with Android. Android itself as a framework also has a couple of resources built in, and this is one of those. Now, most of the time, you will not be using that array adapter, and you will be creating your own adapter. Now, instead of looking at it here, let's take a look at it in the code. Now, the array adapter the adapter in general is a class that needs to implement an interface-based adapter. And for this adapter to actually work, you need to override a few things for this to work. Let's take a look. So let's go to this one here. This one. There we go. Let's clean it very quickly. And I will run it, and I will see the list appearing. So run it. Open Genymotion. So this is Genymotion for the people who have not seen it. So Genymotion is actually the emulator that I use on the Mac. Publishing. It's packaging, actually. Then we're going to publish it. So the clean thing I'm really doing here, because I have several applications with the same name, several demos, and then sometimes it doesn't always uninstall the previous one. So this is what we now have, a list. It's not a scrollable list because of the fact there's not enough data, but this would actually by default be a scrollable list. Let's take a look at how we got that list on the screen. So maximize this here. Well, in this case, I now have a different activity, the coffee overview activity. And this is an activity which inherits from that list activity. Now, do note that you don't always have to inherit from list activity if you have a list. Just put on a list view in your XML and you're good to go as well. Works in the same way. But this makes things a bit easier. This has its built-in view. Notice there's no set content view call here. I'm not calling set this view there. No, not necessary. It has its own view. Now, if we take a look at list activity, come on, opening, yeah, there we go. So list activity inherits, like I said, from activity and has a list adapter built in, and that is linked with this list view already. So these two know each other. So the only thing that I need to do is, well, instantiating a new adapter in that list adapter property here. And I am using a coffee adapter, and a coffee adapter is probably not something that comes with Android, so I've built this myself, passing in the data, by the way, that I want to display. Could come from a service or something. Oops, that's not what I wanted to do. Go to the definition of coffee adapter. There we go. Coffee adapter is or inherits from base adapter, and for this to become an adapter, or let's put it differently, to make this adapter work in combination with my list view, I need to override 4 things. Get item ID returns which item is currently in view. Microphone is slipping away. An indexer, a count. The count needs to be known by the list view to know when you're scrolling, how long is that thumb going to be. And then the last one, and that's probably the most important one, is getView. GetView is called, and let's put a breakpoint here, then you'll see it. GetView is called per row that is appearing in the screen. So this is now called once, twice, 3 times, 4 times, and so on and so forth. Yeah? So by default, if you have an Android screen and it displays, let's say, 10 rows, it can put 10 rows on screen, it will call this getView 10 times. This is virtualization, right? It doesn't, if you throw 1,000,000 lines at it, it will not run this getView 1,000,000 times. That would probably make your Android device explode. You don't want that. So this getView will only be called X number of times, where X is the amount of rows that will be on screen. 10 or 11, maybe 12, depending on the device. But when you start scrolling, rows are going to pop off at the top, and new rows need to be added at the bottom. So what is happening is that if Android has a popped off row at the top, it will put it in a little graveyard. Yeah? And when a new row at the bottom is needed, it will actually pass that view in that convert view parameter here. And that convert view is actually sometimes filled in for you. And if it is, then it's a row that has been already created and is popped off at the top of the screen, or if you're scrolling down at the bottom of the screen, of course. So I check here if convert view is actually null. And if that is the case, well, I need to create a new row then. And I'm doing that using something called the inflate mechanism. Inflate is basically, think of this as you give it an XML file, and it's inflating it to instantiate objects from it. So it's inflating the row. And what am I inflating? Simple list item 1. It's an Android baked-in resource. Yeah. Once I have that, I have my row. Now I need to bind data to that row. And now you need to go to the Android documentation because you need to know which text or which label or which image view is on there, which is the ID. You need to find that in Android's documentation. And in there, you can find resource.id.text1 is actually in the simple list item 1. So we actually bind it this way, and we return it. Yeah? Now, this is using a built-in Android resource. Like I said, this is a built-in resource that comes with Android. Android has, I think, in total, it has around 15 built-in templates. With very, very good describing names, as you can see, the simple list item activated 1, simple list item 1, activity list item 1. They have spent so much time coming up with these names, it's astonishing. but anyway. So what you can actually do is use another of these built-in row templates. Go to your code, and you can actually see that instead of having simple list item 1 here, you can actually dive in and use one of the built-in other Android resources. Now, in most cases, they're not going to be what you need. So you will actually have to create your own template. And that's most of the time necessary because you will need to display an image there, a text block there, and another text block on the far right. So if you want to do that, it's actually possible. A row layout is just XML. It is just plain XML again. So create in your resources layout file, folder, another file, a layout file, an XML file with the layout of your view. That's done. When that's done, then you can actually, this is for example a simple layout, I'm going to show it in the demo. And once that is done, you go to your adapter again, and in your get view, you will not be returning an Android resource, no, you will be returning your own resource. Inflate that, data bind it, and you have your own row template. Right? And you can actually customize your rows. Let's take a look. So, going to another demo here. Number 4. So let's run this first, and you'll see a difference now. You'll now see that we actually have the layout that we had in the very beginning already. So with the image in there, it's compiling. Waiting a second, it's installing. There we go. So now we should see, there we go, we have an image, we have a custom row view defined for our application, right? An image and 2 text views, text labels below each other. Now, let's take a look at the code for this. How was this actually created? Well, in my resources layout folder, I have this coffee row view AXML file. It doesn't visualize because I don't have any data bound to it, so it's not visible. But when we take a look at the source, this actually is a linear layout within there. So it's a horizontal linear layout, as you can see. The orientation is set to horizontal there. And on the left, I have an image view. This one here. Oops, this one. And then I have another linear layout nested. Of course, you can nest these things. Vertical orientation with 2 text views in there. So this is now my thing on the right, my 2 text views. I have my row created for me. Now, in my adapter, I need to make a change. It's not an Android resource anymore. It's now my own resource. Resource.layout.coffee row view, and that will be generated. And once I have that, once that's inflated, I can actually start searching for my controls, for my views inside of my row. And that will actually, in this case, I'm then data binding the coffee name, the price, and the image. Yeah? And I have actually now used my row. Clear? Good to go? All right. Now, we also now need, we have now successfully created the list view, we've created the detail view. Now we should actually link these 2 together. And how are we going to do that? Using something called intents. We need to navigate from one screen to another. Now, to navigate, we can use, or we should be using, an intent. Now, remember that in the beginning of the talk, I told you, you should see Android as a big sea, and all these, and all activities are little islands. And now, all of a sudden, activity 1 or island 1 needs to say something to island 2, activity 2. How is it going to do that? Well, it's going to take a glass bottle, put a little message in there, drop it in the sea. Android picks it up, reads the message, and sees, we need to navigate to that activity. Okay, you're now active. Poof, on screen. That's what an intent is. It's a message between different activities. Activities are a very loosely coupled model. And intents allow us to let these 2 activities communicate without actually knowing each other. It's not that I have to instantiate in activity 1 a new activity 2 and then open it. No, it's a very loosely coupled system. Now, navigation is just one of the things that you can do with intent. There's many, many more things that you can do with an intent. For example, if an activity says, well, the user has clicked on this phone number here. We need to go to the phone call application. Well, in fact, the phone view, so the call view, is also an activity. Everything in Android is an activity. So basically what you're then saying is, well, the user clicked on his phone number, we now need to navigate to the call activity. It's also basically an intent, having the intention to make a phone call. Every time that you say, well, we need to do this, we need to do this particular action, we have the intention of doing something, it's probably that you will have to create an intent. Again, there's many more cases of where you will using intents, but that's where we are going to be using it. Now, an intent, like I said, is a message. You will have to include or say to Android, well, we need to do this, but you also probably will have to include some data. When I say to my phone, make a phone call, it's not going to know where it has to who it has to call. That's the same thing here. We need to include the data, who are we going to call. So, for example, this is some sample code to make a phone call. I'm going to create a new intent, and the type is action call. This is basically an explicit intent. An explicit intent says to Android, I want you to do this. I have to pass some data, the phone number, in a particular syntax that I have to use. And then I say start activity, passing in my intent. And Android will see this and say, oh, it needs to make a phone call. Let's go to the phone call activity, start it up, and do the phone call. If I want to do navigation like in my application, what are we going to do? We're also going to create an intent. We're going to set the class target to which we want to navigate. The coffee detail activity is where we want to navigate. And when I go from master to detail, I also have to include what am I going to navigate to, which is the ID. So you can actually pass quite a lot apart from objects. You can also only pass simple types here. In this case, a key value, selected coffee ID and that coffee ID. On the receiving side, of course, we also have to do something. In this case, I'm going to get of the intent an integer, intent.access gives me access to something called a bundle. It's a dictionary that I can pass between activities. Pass in the key, and I will get back the value. Let's take a look. So, go here, and then go here, and open the solution file. There we go. Do a small cleanup again. Clean, and then run it. And now we will actually be where we were in the very beginning, so where we can navigate from the master to the detail. Let's take a look. Synchronizing. There we go. So when I now click on one of the items here, I will be taken to the detail screen, hopefully. There we go. So what now happened was the first activity threw in that intent. Android picked it up, said, oh, it needs to go to that activity, passing in that data. Activity, you are now active, and this is the data that the first activity is called, has passed to you. By the way, the old activity is now still active. It's not really active, but it's still there. When I do this back here, then the life cycle is actually killing this second activity. That is actually the destruction of that activity happening. So let's take a look. So in the overview activity, that is this one, I have created, so that's a list activity, and there's an override that I can handle for row clicks. So there's an on-list item click, and I'm going to ask which one of these coffees was selected, which one was tapped. I'm instantiating an intent. I'm instantiating an intent here. I'm setting the class to which I want to navigate, the coffee detail activity. I pass in a key value, coffee ID. I put in the selected coffee ID, and I start the activity. On the receiving side, so in the coffee detail activity, in my onCreate over here, I have access to my intent. You cannot do that just everywhere. In here, I'm calling intent extras, get int, pass in that same key, this one here. This gives me access to that ID. I go to my data service, load in the details, and I can display my data. All right? So we have 5 minutes left, so that's just enough to skip fragments and take a look at how we can optimize the application a little bit. Okay, there we go. So optimizing the application. In most cases, applications need to be translated. They go in a store, which is worldwide, and applications need to be localized. Just like we can actually do with IDs, we can also pass in a string value as a resource ID. So for example, here we have a text view, and instead of directly pasting or writing the text here that needs to be displayed, I'm pointing it to another resource, at string coffee name label. And that's a value here in another file, an XML file, that contains text values. And that's a file called strings.xml, and that strings.xml is actually translated, or can be translated for every language that we want. So the value strings is there by default. Do you want other languages? Well, be my guest. Take another, copy that folder, put behind the country code, and then in there you put your translations, and automatically Android will take a look at the current active language, and will pick up the correct language if available. And the last thing that also is in that resources folder was that drawables. And remember, in the beginning we had add drawable icon that was at the top of my activity. Well, that add drawable icon is following the same thing that has been happening with the resources folder. In there, there's a couple of folders, and you can actually point to add drawable icon. Basically, Android will also type what is going to be inside of your resources folder and allow you to access that from code. Now, let me show you that in the last demo. So, let's go to the 7th version. This one. So, there's a couple of things that I need to show you here. Over here we have a file, strings.xml. And in that strings.xml, I have, again, resource IDs, resources. In this case, it's called coffee name label. And I have the translation, it's the default translation, but I have the translation next to it. In my main AXML, I have over here somewhere the text. It's not hard-coded anymore inside of my XML code here, but I'm actually pointing it to an add string coffee name label. If we open the resource designer file, this one, you will also see here a class string which has been generated for me, which also contains a mapping for all these values, and that's how it's actually looking up the languages, or the translations that we want. By simply copying values into values EN, values NL, values DE, you can actually translate your application. And the last thing I need to show you here is that drawable folder. I actually should say folders. As you can see, there's a couple of drawable folders in there with an extension. And the extension points to the pixel density, the DPI, that icon can be used for. Android is used on many types of devices, with a higher resolution, lower resolution. And in fact, you should actually optimize your application so that your icons, your drawables, are in there in different resolutions. And so most of the time in a real application, you'll actually have a copy of your resources in these different folders. Automatically, this is also going to be reflected in your resources folder, in your resources file, your resources designer CS. And that is why you can simply point to it when you go to your application properties and you go to application, Android application, go here, and in the application icon, we can actually now point it to add drawable coffee bean icon, which is an icon in that drawables. Depending on the resolution, Android will pick the correct one from the correct folder. And when that is all finished, well, then you're basically ready to publish your application in the store. Deployment of Android applications in general is typically done, of course, through a store. Now, Android is a bit of the Wild West. Basically, everything works in Android. You can deploy in the store. The Google Play Store is, of course, the most famous one. Other stores exist. The Android store exists. The Amazon store exists, but also non-officials like GetJar exist. But like I said, Android is a bit of the Wild West. You can actually give a USB drive to someone and say, well, my APK file is on there, and you can actually sideload it. You can email an Android application to someone. So deployment in a corporation is very simple. Put it on an FTP or a file share, and you can actually install it from there. So with that out of the way, I hope I've given you a good overview of what Xamarin Android is all about and what you can do with it. It's actually broadening what we can do with our C# and .NET knowledge. There's a learning curve, definitely. You have to understand you're building for a new platform. Android is not a very small platform. It's quite a few things to learn. But with the fact that you can leverage what you already know, I think you're good to go. I hope you enjoyed it and enjoy the rest of the day. Thank you for being here. If there's any questions, we'll take them offline because I think the next... Yeah.